And I'm really pleased because Alex Perchovic from Jampro is with us. And I've known Alex for a long time, and I found that he really has a passion for what he's doing. And I think that's one of the reasons I wanted to invite him because you're going to enjoy this discussion. So, Alex, take it over.
All right, great. Again, Barry, thank you very much. Really appreciate the opportunity to be able to discuss antennas today, the questions and considerations for antenna selection. And again, while this is written largely about FM antennas, it also talks about TV products as well, all about scale. There we go. Important things to consider. Location, site location. While I understand with regard to FM systems, in many cases, that may be somewhat limited or is becoming more and more limited. It is a primary consideration and one of the things that should be really looked at closely. And these are going to be the items that I'm going to be talking about in much more detail here in the presentation. So they'll also be about towers, tower shape, tower height, and how that relates to coverage, transmitter power, and increasing coverage. Antenna types, the various different types of antennas that are available, from side-mounted dipole arrays to various different types of panels, gain versus transmitter power and or tower space, polarization, which in many cases is pretty much limited here, at least certainly in the States, more or less. Signal frequency or broadband applications, are they necessary? When are they necessary? What are some of the considerations there? VSWR specifications for band and bandwidth, directional antennas versus omnidirectional, when and where, pattern optimization and or measurements, and then installation. What's important about installations and or factory testing, and other possible components that maybe people will require. One of the things we see is in this slide here, basically what we're trying to illustrate is how these various different factors, tower height, antenna gain, and or height, transmitter power, all of these things relate back to coverage at the end of the day. One of the things that we're being tasked with while there aren't large numbers of new FM stations, for example, being built here in the States these days, there are some, but we are getting a lot of people looking at how do they optimize their performance? What can they do to, for example, lower their electrical costs, and or still maintain coverage the same or better than what they've had. That's been a big thing that we've seen in the last 12 to 18 months. So loading becomes real important, and the size and shape of the tower becomes really critical in making some of these decisions and perhaps how to go forward. And so it's really essential to look at that as part of the factors in this, because in so many cases, the tower size and or shape is going to determine a lot. In other words, maybe you need a very omnidirectional antenna because of the location and the areas of coverage and interest. But given certain tower sizes and shapes, that may not be possible or practical. Same thing is maybe you're trying to lower transmitter power, but you don't have a large amount of tower space or capacity. And that's another thing that we're seeing a lot of is everyone is quite concerned about their ongoing operational OpEx costs these days in terms of how to lower rent space on towers and so on. So we think these are all important considerations. And then the other thing too is HD levels. That's becoming more and more important. People talking more about that and how they can plan for that if they start to make changes. And what's some of the considerations to give with regard to HD. All right. Location, site location. I think site location, if at all possible, is one of the most critical decisions and for people to make. And while economics, we would like to think are secondary if it's possible, we understand that's becoming more and more difficult. We like to suggest to people to evaluate all of your options. Look at what spaces are available or what locations are available and what does each provide. Does it give you effective coverage of the areas where you want to cover, where your audience is, where you expect the audience to grow to? That's essential. Study those locations and what do you get from them. Proper height is essential and critical. And if you can maintain line of sight to these areas of concern, that's always essential and really important. Okay. Existing sites. One of the things we think is really a good way to start to evaluate things, especially if you don't have a station on the air, is look at what are some of the existing sites that are in operation. How are they performing? Are they performing well? Do they cover well? Are you getting the kind of performance? Are they getting the kind of performance that maybe you would like to see achieved? What's the antenna height, gain, ERP? What type of antenna is it? What's its polarization? Was there anything done? Is it a directional versus omnidirectional? Was there anything done to optimize its performance? Those are all things that can and will play a part of it. Also, the height to horizon or distance to horizon is of importance, depending largely again on the area that you're looking at. We think that that's quite critical in many cases, and much as a lot of people focus oftentimes on the azimuth patterns in terms of optimization, elevation pattern performance is of critical importance too, or can be, depending on the environment, the location, etc. And the appropriate amount of beam tilt and or null fill in an antenna can make a significant difference in terms of the type of performance. All right. Excuse me, in terms of tower height or tower type, what is the tower height? Where is its location? What's its capacity? What's the mounting space available? And as I mentioned earlier, shape. Can you put up a side-mounted dipole array and expect to get the kind of performance you want? Or do you need to really be thinking about some other type of antenna that may be a panel or something else to get the kind of performance you're hoping to achieve? So this is really pretty important. And then site conditions too. What are the conditions like there? Is it a location that has large amounts of snow and or ice? Or is it a place that just has large amounts of humidity? Is it the desert, et cetera? Those are all important considerations in selecting antenna types. And we're finding as a vendor, we're being tasked more and more often with how do we fit into people's requirements with regard to loading capacities and things like that. Transmitter power. What's the transmitter power that's going to be used, and the trade-off between antenna gain and or power? Is there some compromise that can be made? We've been finishing or working on a number of projects where we've been trying, as I mentioned earlier, to help people lower their transmitter powers and increase gain. In some cases, that has meant utilizing more directionalized systems or higher gain antennas and that are omni. So there are different ways of doing it. HD radio. Is HD radio a consideration either now or in the future? And if it is in the future, what's the injection level going to be? Because that's a real important consideration to look at. And then again, electrical costs. Consider operational expenses. What's going to be acceptable for a station? That's important. Pattern requirements. Is the station going to be licensed as an omnidirectional antenna, or is it going to be directional? And what does the station want to achieve? That's going to be really essential to look at this or to consider antennas and antenna types. Also, pattern measurement versus optimization. We know, especially with dipole arrays, you put those on the side of a tower, and while in free space, they're omnidirectional. a side-mounted dipole array is going to have some distortion and scattering. In some cases, that can be beneficial, and in some cases it can be very negative to coverage and performance. So important for people to keep that in mind. And this is an important consideration. If a station is located right in the middle of the market, and they're a class C, for example, it may not be of great importance in that case. But on the other hand, if a station is going to be located outside of a market or on the edge of a marketplace, the last thing they're going to want to see all of a sudden is a large null in the areas of importance. And as Murphy's Law also often seems to apply, and inevitably there's going to be the station owner or someone of importance, an advertiser, someone there. All right. And so where are the receivers? Where are the receivers today? And where do we anticipate the receivers to be tomorrow? Okay. Antenna types. What are some of the different antenna types? There are side mount dipole arrays. And there's various different types of dipole arrays, and I'll show you some photos of those. There's a whole host of panel type antennas, and depending upon the type and size and shape of the tower, various panels can be used. There's top mount antennas that can be utilized as well, for FM also, both a side mount on a pole as well as actual top mount systems. And then polarization. Overwhelmingly here in North America, we are utilizing C-pole antennas almost, I won't say 100%, but almost 100% of the time. But in many markets, we also are supplying vertically polarized, horizontal, or elliptically polarized too. So polarization is important. Is the antenna going to be single frequency? Is it going to be multiple frequency, both currently or in the future? Those are important things to consider as well, both from the standpoint of specifying the equipment and what is required, but also from the standpoint of implementation. These days, the cost of getting crews out to do the work is much more significant than it once was. And so the last thing I'm sure someone wants is to be doing a project repeatedly, because now they want to add a frequency or something like that. The other thing I think is a real important thing that we have been seeing more and more of, and we believe is something for people to consider, is with the implementation of HD and with HD injection levels increasing from 20 dB to 14 to 10, et cetera, voltage ratings are of much more importance. Where power ratings really is about heating, voltage rating is about the gap and arcing. And power ratings, generally, when you're looking at a single frequency type of a system, not so much of a consideration. As long as the antenna is tuned properly, has reasonably flat VSWR and response over the channel, not a big deal. But what we do see is where people are looking at now adding HD to a station or to a system, and then adding multiple frequencies. HD injection can consume a large amount of the power rating very, very rapidly. So that's an important consideration to give is are you going to implement HD? What will the injection levels be? Will there be more than one frequency? And if there will be, what will those will there be HD, and what will those injection levels be? Because it can have a significant impact. And then if we're looking at multiple frequency systems, what kind of VSWR bandwidth are required? That's important. I've also put one thing here, materials of antennas and insulators. This speaks a bit to the issue of voltage and power ratings, but it also speaks a little bit or much more to environmental conditions. What are the conditions in which these antennas are being installed? Are you putting something that has tremendous amounts of solar issues and sun? Are we looking at some place that has a large amount of snow and ice? Those are all real important things to consider. Or that is it on the coast in a very harsh environment? Is it near factories, refineries, and those things? Some materials don't do especially well in some of these environments, and a little bit of consideration can help the system last significantly longer by considering that. Again, on gain and antenna considerations, what's the gain of this system need to be? Are we, what's the classification of the system? How does it compare with regard to the transmitter? What makes sense? What kind of operational expenses of the state is the station trying to achieve or trying to maintain? Maybe that's another way to put it. All important. Okay. And then I talked earlier about voltage ratings versus average power ratings and VSWR, and materials. Antenna types, vertical Yagi style. This is an example of a vertical Yagi, very broad band, covers full band. It can handle multiple frequencies, fairly significant amounts of power. Ideal for some of the lower power applications and stations out there. Circular polarized Yagis. This is another product that is being used more and more, and we're seeing this. And again, it's very directional, full band, FM, multiple frequency. Log periodics. Log periodics are a vertically polarized element, can be slant polarized or E-pole, so very directional. Can be put together 2 or 3 across to make a very, very narrow load. Very broad bands. Ideal for SFN applications like max casting, the geocast, and other solutions like that. Vertical dipoles. Vertical dipoles, one of the more common products that we've been using for years and years and implementing. Ideal in many applications. Could be here in North America, ideal for example, an auxiliary station or an auxiliary facility for a group of stations in a given marketplace. These can handle reasonable power levels, 5 to 10 kilowatts per dipole. So you could have a full band FM system like this that would allow multiple frequency operation, either combined or individually. Ring stub style. A ring stub antenna, this is historically typically a lower power antenna, has limited bandwidth, typically single frequency. RF levels on this style of antenna are not as ideal as some of the cross dipoles, and so RF levels of up and down are typically run a bit higher. Rototiller style of antennas, great in really icing conditions and really harsher environments. Good for multiple frequency types of applications and bandwidth, but again, higher loading. So it's a question of capacity of the structure and what can it handle. Penetrator style or cross dipoles, lower loading, good bandwidth, okay for multiple frequency types of applications over a segment of the band, but not a full band system. Radomes and de-icers for icing conditions. Broadband penetrator style. This has been something we're seeing a lot more of than we have in years past. Broadband antenna covers most of the FM band or at least a large segment of it. It's good for multiple frequency applications and can be, some of them have radomes for some of the harsher environments. A very broadband style of antenna is internally fed. This is a full band style of antenna that has really good bandwidth, but it has very high loading. And but again, if there's an application where someone's looking at not installing a panel, but they need the bandwidth similar to that, this is an ideal type of product. Panel antennas. What type of panel antennas are out there in the marketplace? They're flat panels, cavity style, and then top mounts. I'll show you those. A 3-around circular polarized style of panel. typically internally fed, full band FM, great bandwidth, good for multiple frequency applications, can be directional or omnidirectional. Four dipole or a four around type of a panel. Also very, very broadband, ideal for multiple frequency applications. Can be placed on larger towers and can be either directional or omnidirectional. Crossbow. Crossbow is another kind of a hybrid antenna between a style like the arrowhead style and the four dipole. Intended for either three around or four around types of applications, very broadband, and ideal for multiple frequency types of applications. Cavity antennas, again, very similar to that of the crossbow and the others. It has a bit more isolation between the two and really good axial ratio, but ideal for directional or omnidirectional stations. Vertically polarized panels or horizontally polarized panels. Those are very broadband, can handle various different power levels and directional or omnidirectional. Top mount, lambda style antenna. This is a circular polarized, omnidirectional, full band FM antenna, ideal for multiple frequency types of applications with good axial ratio. It's an antenna that can be slightly directionalized, but mostly an omnidirectional antenna. Batwing antennas, they're a horizontally polarized system, which is not as common for FM, but in some cases, we've seen people utilizing something like this. They have great bandwidth. Things that we think are of a great importance when looking at FM antennas or antennas in general is, and a critical aspect of the supply is, how are they tested? What's done in terms of testing? Are they fully assembled or not fully assembled? Are they just single elements being tested and measured? Are they being put up on towers similar to that in the field and factory tuned, or are they being supplied with a bandwidth and or specification that is close to what people want to see achieved in the field, and then with field matching, they are then slug tuned to get them to perform as people would like, or at least make the transmitter happy. We think this is an important consideration and something that is not, a lot of people don't give a lot of thought to. We believe that it is very important that antennas should perform as efficiently as possible. And the implementation of that antenna and the factory tuning is a critical part of that. Getting maximum efficiency from the systems is essential, not just making the transmitter happy.
Alex?
So we think, yes, sir.
I'll ask a question here, and so others may have questions. First of all, factory testing. A lot of stations think that they can save $4,000, $6,000, $7,000 by not doing a field test. I think it's very important. And can you explain briefly why this is so important to do?
When you say field test, Barry, are you talking about pattern performance or
Yes,
what aspect?
On the test range.
Sure. Well, I alluded to it earlier. You put an FM antenna, let's say, for example, a side mount dipole array of some type, on the side of a 5-foot face tower, 8-foot face tower, 7-foot face tower, whatever it happens to be, and that is not optimized for that FM antenna. It's a TV tower, let's say, for example. That's going to play some havoc with the azimuth pattern. It's definitely going to distort the pattern. And in some cases, that may not be an issue, but in many cases it will be. And so we think that that's an important aspect for someone to have information and knowledge on how they might want to mount an antenna to minimize areas where they don't have coverage. Does that make sense?
Yep.
That's important. We also think and Barry, what I'm relating to or referring to when I say factory tuning and factory testing is environmental conditions play a large part in what vendors can do in terms of testing. In other words, in some places you may not be able to test the equipment 365 days of the year because of the environmental considerations. Or you may have to do certain levels of testing or types of testing because of those environmental conditions. And that's important. It means that how product is provided and at what specifications it's provided are of importance.
Why you need to know exactly what tower or what, if there's a pole, how that is being mounted.
We prefer to know that, and we suggest that people consider that and give that a lot of time and consideration as they go about implementing these systems. Absolutely.
It can be very quickly, a pattern can be turned around
Yeah,
because of parasitic effect of a tower or
right.
something like that. It just really makes a lot of sense to know what that tower, that antenna is going to do.
It does. It really does. And I can refer to many projects all over the country where I know that this is done and made a significant difference in terms of performance in major markets all over the country and in some smaller markets. So I think it's a consideration that makes good sense. Really
Have you ever
does.
had somebody come back after you've sent an antenna out and they didn't do a test and say, can you do a field test for us on this now?
Oh, sure, sure. We've been involved with that on numerous occasions. Numerous occasions. That's right. Hmm.
We have a few
Definitely.
comments in here. I'll just mention them. Um, Ray Lewis mentions that you got the patent for the slant dipole radiator in the 70s. He
Hmm.
says the most copied FM antenna ever.
That's true. It is. It is. It's yeah. If flattery is, any reward or anything like that, it would be that. It is by far the most copied FM antenna. No question.
And that goes back to the history of Jampro, and it's not a company that just popped up a year or two
No,
ago.
no.
You guys have been there quite a while, and there you are. Ray also mentioned that several folks get bad results by mounting their low gain FM antenna only a few feet above the ground on mountains that have large flat areas.
Mhm.
Need to consider very local Fresnel zone clearance and multipath effects at the top of the mountain. Low gain antennas can strongly illuminate the large ground area on the top of the mountains. And I'll add to that, with all the attention now toward diplexing and triplexing to save money by getting off one tower and sharing,
Mhm.
you could get too low on a tower if you're not paying it proper attention, or you could end up in a situation where your signal is just not going to make it where you think it's going to go.
That's right. That's right. And we've seen the same thing on building tops in a number of cases where um, the space available was very limited, and the height was supposed to be ideal and make a big difference in the performance of the station, and ultimately it didn't. But yeah, they needed to look at how to move the antenna or to a higher elevation to get clear line of sight. That's essential. Really is.
Ray also mentions that you're using HFSS to model an antenna to a tower.
We do. That is one of the tools that we use in modeling pretty much everything that we do anymore. If there's any one thing that has changed more than anything else in terms of antennas, filter, and RF component design, is the tools that we use. Today, we don't cut metal until we know that it performs and it meets the requirements.
And still, even if you do model it, you still want to do a test range, don't you?
It depends on what style and type of antenna it is. In some cases, yes, but not in all cases. For example, we're right now in the process of preparing to do full factory testing on a 14 frequency FM system that each half will handle a little over 120 kilowatts and have 14 FM frequencies combined. It's a very, very large panel array. And we'll be measuring patterns, we'll be measuring VSWR, we'll be doing a whole gamut of testing.
That speaks to a whole room full of filters and
Oh yeah.
diplexers,
Yeah.
triplexers.
Sure does. And a very large area to assemble an antenna like that to test. Really does. Very large. So.
Any other questions at the moment, friends? If you do, press your space bar or alternate A to unmute your microphone, and feel sure that Alex would love to have your question.
A couple more slides I've got here, and anybody has questions. I think also installation. We can't overemphasize how important that is. It's critical. We can do all types of things and go to great lengths to produce a product that meets the requirements of a station. But if a crew is not qualified, if they don't have experience, if they don't appreciate some of the things on site, and mind you, this is not going to be for all applications and all projects. We're not, small 2-bay antenna doesn't make sense to have a crew come out or a technician come out. But the fact is where it warrants, it's really of importance. We've all been aware or I've heard of some of the horror stories we've had. We've all had where a crew installs something and it's not right, and they're doing what they understand is their job, but they don't really appreciate some of the nuances. And especially, Barry, as you're talking about some of these multiple frequency broadband systems, they become a lot more critical. And very, very small things can have a tremendous impact on the performance ultimately. So it's essential, really is essential to keep in mind when you consider.
Do you find a tower crew will optimize for one station to the detriment of two others?
No, I won't say that that's been my experience, but what I will find is, or I will see is that a crew, it looks at an antenna as a very mechanical aspect or portion of a tower, kind of like putting tower lights on and not really looking at what the purpose of the tower and what the purpose of the antenna is. And that it is to achieve something, whether that is with respect to coverage, combining, et cetera. And if they are not giving, especially in more critical installations, if they're not giving great attention to details and how things are to be assembled, it can be very expensive for all involved to find, that needle in the haystack, so to speak.
Mm-hmm. Thank you.
Yeah, sure. I think the other thing just to keep in mind too, other components that are all part of these things, along with antennas, are things like rigid line and rigid line components, elbows, couplings, et cetera, bullets, patch panels, quick release patch panels, important when installing these systems. Combiners and filters and switches and loads. Those are all things that may need to be considered and looked at as you go through a project and are looking at how to implement a system as easily as possible, put it that way.
All right,
Any questions?
I'll ask another question here about multiplexing in particular. Obviously, if you are putting different antennas up, each antenna can be optimized for that frequency. If putting a panel up, and you say broadband, what do you mean by broadband?
Yeah, I'm glad you brought that up. There's a lot of misnomers on what broadband really means. For years, there was a lot of people calling certain types of antennas broadband. That doesn't necessarily mean that they really truly were broadband. In some cases, what you saw were just the effect on that style of antenna environmentally. Icing, for example, was maybe not as pronounced or as significant as a result of the physical size of the element versus others. But typically, the way we define broadband is something that is covers the band of with which we're operating. For example, in FM, a broadband antenna to us is something that is certainly more than one frequency or one channel, and likely is somewhere between 6 to 10 megahertz, 8 to 10 megahertz, if not the entire band of FM band. What's important to understand about that is how that is achieved with regard to engineering of an entire system, of an entire antenna system and feed system to be able to accomplish that.
All right. Then I'll ask a question that relates more to some stations I've heard have decided to go from circular back to vertical polarization because of multipath issues, particularly in cities. Have you found this to be so?
I haven't seen that so much. I've seen that more is where people were looking at trying to reduce operating costs, and they found that that was a way they got almost as they got acceptable performance with V-pole only as opposed to circular polarized, and it helped them to lower their costs. But I've also seen several people who've gone to linear polarization and weren't satisfied and recognized or realized very quickly that the sacrifice that they were making was not as ideal.
Over the years, I've worked with a 1 bay, I've worked with a 12 bay, and several in between. Sometimes people think the whole idea of 12 bays is simply to save power, but you can get in trouble to go into 12 bays, can't you?
Absolutely. It depends on the environment, depends on the location. There are markets and places where using a higher gain antenna and lower transmitter power works very well because of the environment, the topography, for example, or the market itself. Maybe there aren't so many large buildings, etc. But there are also places where it's not ideal is to have such a high gain antenna. And if you do have such a high gain antenna, it might mean that you need to incorporate large amounts of beam tilt or especially null fill to fill the nulls and get more a uniform illumination from the point of transmission through the market.
Please
And
explain beam tilt and null fill as opposed to again, realizing, and I suppose I should have specified, or you can, when you get to 12 bays, you really compress that signal pretty flat.
yeah,
You can overshoot your market.
you can, depending on the height. I'm going to go back to a slide that I have here that shows basically distance to horizon. And this is a way you can calculate what those distances are, looking at an elevation pattern, what's the distance and so on, to the first null, to the second null, and so on. And absolutely, if an antenna is too high a gain, it can definitely, in some cases, overshoot a marketplace. And so that is something to give thought and consideration. In one of the things that we saw, especially with digital TV, was uniform illumination, both in terms of azimuth and elevation. And we've had some clients who were very, very concerned about azimuth, how omni or how uniform the signal was. And that to them was of importance. But we've also seen mostly a lot of people paying attention to vertical polarization, or the elevation pattern, I should say, and maintaining a very uniform field. So there isn't tremendous variation between minimas and maximas through the elevation.
So null
Now,
fill and beam tilt.
Yeah. Oh, to answer your question, sorry. Beam tilt is basically where we're steering the beam down, typically, toward the earth. So the question is, how much might we steer it downward, et cetera. You can see in this particular illustration here, it shows the distance, the tilt below the horizon is 0.278 degrees. So it's 25.6 miles. And so in this case, we were put in beam tilt to steer the beam closer or toward the ground. Null fill, and first off, going back to beam tilt, how do we achieve beam tilt? We change the relative phase of the elements at the top and bottom of each, let's say for example, each half of the antenna. So in a 12 bay, between bays 1 and 2 and 11 and 12, there would be some variation there to implement that. Same thing is true with respect to null fill. There's some variation that we would change to improve the amount of energy in the first null. And when you add null fill, when you increase the amount of energy in the null, we generally, it depends largely on the number of bays of antenna and so on, but typically we don't see a significant impact on gain when we add, say, 5, 10, maybe 15% null fill, depending on the antenna type and numbers of bays. But where you get above 15%, you'll start to see the gain drop on the antenna. And in some cases, that's okay. Maybe that is actually part of the consideration and the design by the customer and by the broadcaster. Is they're going to go to a higher gain antenna in order to put a whole lot more null fill in it and fill, again, more uniformly illuminate the marketplace.
I would imagine that you really can't say there's a sweet spot of the number of bays against the power level.
No.
Many people go to a 6 or a 4.
It depends on, it really depends upon what classification of the station it is, class A, B, et cetera, and the location, the area where it's going to serve. That's really of importance, really of great importance. If you're out in the middle of U.S., rural America, you really don't need to have a high gain antenna works usually quite well. You get into places like some areas around Los Angeles, some areas on the East Coast, Boston. Boston is especially one that's been a bit problematic. Seattle, Portland, some areas of San Francisco, really difficult. And getting good solid coverage in those markets consistently is difficult.
Let me pose this question then. And folks, hey, don't make me come up with all the questions. You've got some, I'm sure. Alex, if you're going to have two stations combine on an antenna, on a tower, is it easier for them to combine into a single antenna, or do they need to go to flat panel right away?
It depends on the frequencies. We have combined in a single frequency, or excuse me, in a single antenna, side mount antenna, as opposed to a panel, 8 or 9 frequencies, and they were fairly significant power levels, class Cs, for example. So it is possible. It just depends on the particular application where it's being done.
Sure.
Numbers of bays, those types of things.
Sure. And of course, the number of antennas for different stations mounted on one antenna, a tower, that can have a great effect too. I've seen sites where there are 6 or 8 different filters strung in a row to prevent intermod.
Sure. Oh yeah, absolutely. No question about it. That's right. That's essential, isn't it?
And sometimes a combiner is easier than than all those filters, and
all the filters, yeah.
Which they all cost you power.
Yeah, they do. They will.
So,
depending upon how efficient the filter is or isn't. That's exactly right. It's very true. It's good.
If you're dealing with a single frequency, what's the what's the need for an antenna that's broadbanded for the entire band?
Um, there may not be one, to be very honest with you. I believe it's rich. You, the one thing it would allow you or permit you to do is add other frequencies perhaps at a future date. That's the one thing that it allows. Um, if not, it's really not a necessity. It really isn't.
And
another
why?
And
aspect would be icing, as you said earlier.
yeah, that's true too. Is it depends on if you had an environment. Let's say you had an environment that gets some significant icing and icing accumulation or ice accumulation. Absolutely, having something that's more broadband when ice accumulates and it detunes will give you maybe more range that it can detune over without VSWR folding back on your transmitter.
Now, why do you consider Boston to be a problem?
Well, historically, we did a number of projects there in the mid to late 80s where where it was very difficult. The stations where the FM stations were located on larger towers and they had really difficulty in covering the entire market with a good solid signal. And I know that in recent times, SFN was installed there to gap fillers basically to help to improve the signal of various stations.
When I was in Boston, almost everybody was, mounted on the TV towers
Yeah,
outside the city.
yes.
I'm noticing they're now downtown on the Prudential and other tall buildings.
Hmm. Yeah. And I know we did a number of antenna projects there on some of those TV towers to improve the performance. The antennas or the antennas were mounted on the side of the tower, and I believe the towers were 10-foot face towers. They were rather large, and we found that the pattern performance, the azimuth pattern performance, was less than ideal.
Hey, Alex, this is Ray. Yeah, I was telling Barry, you got one of our best antenna engineers several years ago, Marguerite Ralston. But anyway,
Good.
she's still doing good. I was just wondering with HFSS, we use that a lot, and I wonder if you've tried IcePack. As you start combining all these antennas into one feed, you're right, the average power can start to be a limitation. And there's a new feature with HFSS. Hasn't been out long for forever. It's a multi-physics package. I think it's with basic HFSS for doing thermal analysis. I wonder if you've tried that yet. I know it's got multi-pactor. It's had that for a while. And that's good for peak power breakdown, like you're talking about. But the flip side of that's the average power. That's been a problem for quite a while. And I was just wondering, you're getting so much power and so many stations now with your duplex, your combiners now. Are y'all considering low PIM filter designs now? Because we tend to do that some, for the aerospace. Now there's particular filter designs, the stub cavity type filters that have lower PIM. I don't know if that's starting to become a thing and with your combiners now or not, or
Sure.
all traditional.
We have not looked at lower PIM filters that I'm aware of. I don't believe we have for broadcast, FM or TV broadcast. I do know that we had some. It's been several years back, but we had a client who was interested on the UHF panels for us to look at PIM testing. They wanted us to look at that as part of the supply. But it's not for broadcast. It's not been all that common. The thermal analysis, I believe our folks have been using that. I can't myself speak with great knowledge of it because I haven't been involved with that. But I can certainly find out more and see where and how they used it. If you want to send me
No,
an
it's
email or
just been
something.
it's been a game changer for us. I mean, this is the past year or two, and there's a little bit of a learning curve, but
Mhm.
boy, we've done some really high average power systems, and then you can go in and add cooling where you need to, and see where you're going to have a problem before you have a thermal issue. So it's saved us a lot of money. But
That's
in
great.
I think it's part of HFSS now. So
Okay.
ice
Okay.
pack.
Ice pack.
Yeah.
Okay. I will definitely ask about that. That would be great. Thank you.
I have a question. If you have you had any customers come back to you and say, we mounted our antenna too high, we'd like to relicense at a lower power level, perhaps to improve building penetration or other such concerns?
Hmm. I can't say that we have. Let me say this, I don't recall any such request or application
Oh,
here or anywhere else.
okay. Where I'm coming from, I tend to be of the mindset that there is no such thing as too much height, but
Sure.
I am looking at building a Class A, which is less than full A. It's in the non-com educational part of the band. That started off, it's currently a construction permit for 6 kilowatts at shorter than 30 meters. I have found a good tower site that would be 400 feet above average terrain, which at that same coverage would drop its power level to considerably less than 1 kilowatt, perhaps less than 500 watts, to yield the same 60 dB contour location. I'm wondering, am I going too far in the other direction?
Yeah, sure. Sure. Um,
It'll certainly save on the power bill.
yeah, definitely would. Wouldn't it? Wouldn't it? I don't know. I guess I think it would be something. My thinking, John, would be is to look closely at the site, look at the location, and some of the particulars of the environment and the area around there where you want to get signal, and because you said what was the height of the site again? It was fairly significant.
400 feet. It's in a flat area, so let's just say 400 above average terrain.
Okay, yeah, yeah. In an environment where it's relatively flat, that's probably not so bad. And I don't know what the clutter is like, and if there's a lot of buildings and other things, that's of importance, but probably not going to be terribly detrimental.
Okay, well, that's encouraging. That's kind of what I thought, and it is pretty uncluttered, and the tower is fairly close to the center of the target coverage area too, which helps.
That helps a lot. That helps a whole lot. How large is the tower? Is it a large, like a self-supporting tower or some type of a guide mast?
It's guide.
Mhm.
I don't know the exact face width, but I think the spot that we're going to get is up on, it's basically a pole mount clamped to the candelabra at top.
Mhm. Okay, that's good. Yeah, and pole mounting like these side mount FM antennas like that um, is probably one of the more ideal mounting arrangements if it's at all possible. The H pole component will be extremely omnidirectional. The vertical will get shaped by the vertical reflector or the pole. Um, but the H pole is going to be really omni. So if you have an area that you want to favor in particular, that's probably not a bad thing to be thinking about or considering.
Well, right. By the way, I do want to give a shout out to you folks. We've used one of your 12 bay penetrators here in southwest Kansas where it's relatively flat. So we can have a pair of 100 kilowatt stations diplexed into the same antenna with TPOs of 18, 18.5, and it's been working pretty well for us.
Excellent. Well, great to hear. Very good to hear. That's wonderful. That's good.
Well, by the way, not to dominate everything, but I had put this as a question in the chat. Where is that 14 bay combined antenna you speak? Is that here in the US or is that
It's
elsewhere?
it's going to be in Canada, in Ottawa, Canada, for CBC, and it's at a location that it will be at a location called Camp Fortune. It's 15 minutes from downtown Ottawa, 20 minutes from downtown Ottawa, up on a hill, on a 1,000-foot guide tower.
I don't understand why people are putting radomes around a lot of FM antennas, especially here in the South where we don't get a lot of icing. We just had one that caught on fire, the Weston Peachtree Plaza. You probably heard about it.
Yeah, I heard
So-
about that. It was a Cox antenna.
You know, yeah, but I don't understand why you really need it. If you have a pretty broadband antenna, nothing terrible is probably going to happen with the amount of ice that we typically get down here. And you could have a once in a lifetime event, but
Sure. Yeah, and that antenna, those radomes in particular are really rather large too. They impose a significant load on the tower. I think, you know, it's through that area, when you get icing, it seems that it is fairly significant. And so I think people are a bit conservative and careful, and they just don't want to have an environment or a situation where they're off the air or at reduced power for an extended period of time.
but the flash point of those plastic radomes is pretty low compared to everything else, I think. So I mean,
Should be,
if
yeah.
something's going to catch on fire, that's what it's going to be. We've seen several of those. So.
yeah. That's
In
unfortunate.
Boston, we had the first RCA circular polarized antenna. It was 2 bays at about 1,100 feet, just below the candelabra in Needham. It caught fire. It was on the air one night, and the one listener called and said, "There's a fire on your tower." We were still on the air. But it was obviously in Boston, it was protected.
Interesting. Yeah. Huh.
Alex, Bill Dawson wants to know why Los Angeles is a difficult city.
Well, if you look at where a lot of those stations are located, they're on Mount Wilson. And, you know, from Mount Wilson, you look at the depression angle from Mount Wilson down into Burbank, for example, and some of the areas, you know, it's at a very, very extreme angle. And that's a great example of a marketplace where overshooting the market is really a problem or potentially a problem. And so it's something that has required a lot of consideration and thought.
Could be easy to do.
It is. And that's why a lot of these systems that are there historically have been fairly lower gain antennas, trying to control the elevation pattern and keep energy strong or high down at the base of the mountain. And even if you look at the antennas that are over off of Flint Peak, for example, if you look at the highways coming in, I guess is it Highway 5 and 110 or 210, there's a fair amount of shadowing in some areas. The towers are not that tall, and so there's areas where they're shadowing, and they're shadowing over in San Fernando Valley as well.
Interesting. And yeah, you could certainly see where beam tilt and null fill and setting the right angle for your antennas is critical for Mount Wilson and any of the standby locations.
It is. It's really, really important, of great importance. That's right.
Before I let you go, I just want to ask a little bit about combiners. You did a big one down in Miami, was it?
We didn't do Miami. Gosh, I think which one?
Where am I thinking of? It's one of the biggest combiners out there, is what I recall.
Seattle. We did Seattle.
Oh, yeah.
We did Salt Lake City up at Farnsworth Peak at 11,000 feet. That's got 15 or 16 frequencies combined. And we did the antennas and the towers there. There's several others. There's a lot all over.
Well, it just shows that you have the experience, and if stations do want to combine, they have a good place to go.
Yeah, we like to think so. We do a lot of work with Arkiva too. While Jampro is based here in the US. Allen Dick, our sister corporation, is in the UK. And Arqiva is the largest broadcast network operator in the world. They have over 2,000 broadcast sites, broadcast only sites in the UK. And 80% of those sites are Allen Dick towers, antennas, combiners, complete, everything. And we supply a lot of equipment for both here in the States as well as in the UK to Arqiva. We're for both UHF TV as well as FM, DAB, etc.
Well, I certainly appreciate your taking the time. And before I finish here, why don't you bring back that slide with the contact information? It's
Sure.
it's pretty straightforward. Jampro.com and 916-383-1177. And you guys will answer questions and help folks get their ideas is what they can improve, how they can improve, or get information about their towers.
Absolutely. Thank you. Very greatly appreciated. And thank you all for taking the time to spend some time talking today. It was a pleasure.
Thanks again. We'll have you back, Alan.
Look forward to it. Thank you, Barry.